Isaac Newton was a 17th and 18th century English physicist and mathematician known for laying the foundation of classical mechanics throughout his three laws of motion and his law of universal gravitation. Newton suggests that all movements adhere to three main laws formulated in mathematical terms and that imply the concepts of force, which is any type of push or pull of an object and is measured in newtons, and the concept of mass, which is the amount of inertia of an object. And inertia is the tendency of bodies not to change their state of rest or movement. Newton's first law of motion, or also known as the law of inertia, consists of every object continues in its state of rest or uniform speed in a straight line as long as no net forces act on it. For example, when a ball is at rest, it will not move, but if I apply a force on it, it will move. Another example is when a car drives in a straight line and will keep moving in a straight line, unless an external force deflects its path. Newton's second law of motion, or fundamental law of dynamics, consists of the acceleration of an object is directly proportional to the net force acting on it, and it is inversely proportional to the object's mass. The direction of the acceleration is the direction of the net force acting on the object. This means that the greater the force acting on an object, the acceleration will be proportionally greater. For example, if we push a chair with no one on it, its acceleration will be greater than if we push with the same force that same chair but with someone on it. Thanks to the weight, it will take more force to obtain the same acceleration. In short, the trajectory is the result of the magnitude of all the forces that act on an object. Newton's third law of motion, or principle of acting and reaction, consists of when one object exerts a force on a second object, the second object exerts an equal force in the opposite direction on the first. That means that when you push something, that something pushes you. For example, when two equal oranges collide, they will move in opposite direction with the same acceleration. But if an orange collides with a heavier fruit, the orange will have a greater acceleration. In conclusion, these laws are the basis of mechanics and have helped to understand planetary motion when combined with the universal law of gravitation. In addition, Newton's laws have also been decisive in understanding and explaining how machines work.